A small slip in wet Ice Age mud, a child skids, an adult steadies their stride, and a string of bare prints crosses what is now White Sands, New Mexico. Preserved for 21,000 to 23,000 years, these tracks surface today to challenge a tidy origin story. Who left them, and how did they reach this inland desert? The answers upend our timeline. At Alkali Flat, rangers notice odd impressions along a dry lakebed. At first glance, they read as megafauna, mammoths, ground sloths, saber-toothed cats. But as light skims the surface, heel-to-toe anatomies appear. A slip mark, child-sized steps, overlapping trackways across gypsum. Researchers cast and map the trails. Soft sands preserve micro-ridges and toe splay. The gait reads human, men, women, and children moving across wet ground. Some prints flare as if under a load, others quicken through mud. What began as animal forensics becomes a human diary pressed in silt. The question shifts from what species to what moment. How old are these steps? And how far back do they push our origin story? At the height of the last glacial maximum, ice sheets smothered much of North America. Sea level lay approximately 120 meters lower, revealing vast continental shelves and the Bering Land Bridge. Far from a frozen waste, southern New Mexico was a wetland mosaic fed by Pleistocene Lake Otero. Grasses and conifers fringed shallow water where mammoths, camels, dire wolves, and giant ground sloths browsed and hunted. In this setting, people moved along shorelines and basin edges, leaving prints where mud held shape. How they arrived remains the core tension. Overland through Beringia and interior ice-free corridors that opened episodically, or by boat along a kelp-rich Pacific highway, offering predictable food and rapid travel south. The landscape could sustain either strategy, and the footprints show someone had already mastered it. White Sands was once shoreline, Pleistocene Lake Otero pooling across the basin, feeding marshes that breathed in and out with seasons. Along these margins, gypsum-rich mud took impressions like plaster, heel cups, toe splay, even the drag of a slipping foot. Alternating wet and dry spells sealed the record, silt, crust, silt, preserving trackways that braid with megafauna. A sloth pivots, a mammoth overprints a human stride, then veers. For people, this was pantry and pathway in one. Fresh water, reeds, birds and game, concentrated at the edge. Camps would have been light and mobile, leaving little behind, but the routes to water were predictable and sticky. The lake framed daily life and, by chance, saved it. What it could not tell on its own was when. In 2021, the first clock was set. Radiocarbon dates on rupia, ditchgrass, seeds from the same layers as the tracks pointed to approximately 21,000 to 23,000 years ago. The headline was explosive and immediately contested. Aquatic plants can absorb old, dissolved carbon from lake water, critics argued, making young material read ancient. If the reservoir was skewed, the timeline could be too. The team answered by multiplying clocks. In 2023, they ran optically stimulated luminescence, OSL, on the sediments, measuring when quartz and feldspar grains last saw sunlight, when the mud lay at the surface to take a footprint. In parallel, they dated terrestrial conifer pollen with 14C, sidestepping the aquatic reservoir problem. Independent methods, same window, late Pleistocene, approximately 21 to 23,000 years ago. To press the case, a 2025 study cored the site. Long cylinders of layered mud capturing seeds, pollen, and organic fractions tied stratigraphically to the track horizons. Those samples went to independent labs, The dates clustered between approximately 20,700 and 22,400 years ago, aligning with OSL and the earlier seed and pollen results. In all, 55 radiocarbon ages now bracket the footprint layers. Could every clock be wrong in the same way? Statistically possible, practically unlikely. Skeptics still probe the lake's carbon dynamics, but the weight has shifted. With converging clocks and tight stratigraphy, the footprints increasingly anchor a simple claim with radical implications. People stood here deep in the last glacial maximum. They were mobile hunter-gatherers, small bands, perhaps 20 to 30 individuals, threading wetlands where water, reeds, birds, and big game converged. The trackways read like a roster, diminutive steps that dart and pause, broader, deeper impressions that flare at the heel as if burdened, a sudden skid where someone lost footing. Stride lengths imply mixed ages and statures walking together, not a lone scout. Overlaps with sloth and mammoth paths hint at pursuit, avoidance, or opportunistic shadowing. No ornaments, hearths, or campsites remain here. Only gait, spacing, and pressure telling of families on the move. Two paths contend for how bare feet reached this basin. One is Beringia, a subcontinent of exposed steppe between Siberia and Alaska, open in pulses between approximately 30,000 and 15,000 years ago. From there, travelers could have threaded south through interior corridors as ice sheets retreated. Slow, seasonal, and risky, but possible with herds as guides. The other is the Pacific Kelp Highway, a chain of rich coastal ecosystems where fish, shellfish, marine mammals, and seaweeds offered a predictable pantry. Simple watercraft hugging shorelines could leapfrog fjords and headlands, skirting glacial walls long before inland routes were viable. The footprints don't choose for us. They merely prove someone had already made the journey by approximately 21 to 23,000 years ago. Whether by foot across wind-scoured plains or by boat along surge and rockweed, these were adaptable people. The unresolved route isn't a weakness, it's the live wire driving the debate forward. Skeptics ask the blunt question, where are the tools, camps, bones? Wetlands are generous to footprints and cruel to campsites. Organic shelters rot, fires scatter, and light gear leaves scant trace. Far from quality stone, mobile foragers treat blades as lifelines, carry them, resharpen them, lose nothing if you can help it. In sticky lake margin mud, you pass through, not settle. The prints are the thing that survived, direct, datable presence. Yet absence still nags, keeping the search alive along older shorelines, dune toes, and wind-scoured benches beyond the marsh. For much of the 20th century, Clovis-first set the clock at approximately 13,000 years. Sleek fluted points, mammoth kills, sudden spread. White Sands pulls the hand far earlier, yet it doesn't stand alone. In Chile, Monteverde, 14,500 years, preserves seaweeds, wood, and tent-like structures. In Idaho, Cooper's Ferry, approximately 16,000, yields tools beneath later sediments. In Texas, a pre-Clovis horizon, 15,500, at Buttermilk Creek, extends the toolkit deeper. More contentious claims, like a high-altitude cave in Mexico reported at approximately 30,000, signal how far the debate can stretch. Taken together, these sites sketch dispersal as a process, not a moment. Coastal foragers tracking kelp-rich shores, interior groups moving along rivers and open basins, technologies adapted to place rather than a single starter kit. White Sands adds something rare to that picture. Direct, datable presence, bare feet on Pleistocene mud, anchoring the timeline while arguments around it continue to evolve. How robust are the clocks across the basin? Do more OSL horizons and terrestrial 14C samples replicate the same window? Can lake carbon dynamics be modeled to bound any reservoir effects? Where are adjacent camps, butchered bone, or tool stone quarries on drier benches? Offshore, drowned paleo coasts may hold answers. So might genetic signals from ancient remains. Next steps: tighter stratigraphic mapping, more cores, targeted surveys beyond the marsh, and Bayesian syntheses that test competing migration routes. White sands brings prehistory to scale, bare feet, a stumble, a path across water and light. With converging dates and a widening mosaic of early sites, the question isn't if, only how people came and how far those journeys reached. Thanks for watching. If you'd like more deep dives into discoveries like this, please subscribe. Share your take below, land bridge or kelp highway, and we'll see you in the next video.